Hello, my name is John, and for the past few weeks, my partner Stephan and I have been studying how nature can affect modern design. We've been specifically looking into insects. Insects live in some of the harshest conditions known to man, and over the years, they have evolved to be able to adapt and live in those conditions without suffering severe harm. So we were looking into how the aerodynamics of these certain insects could maybe influence designs in the present day, and if we can learn kind of from how they have evolved.
In order to observe the insects, we decided to build a wind tunnel, as you can see in this picture. We decided to build the wind tunnel out of wood and plexiglass, and so that we could observe the airflow over the insect inside the wind tunnel. Here's an inside look of what the wind tunnel is. We have our stand for our subject, and then in the back you can see the tube where the mist will flow out, and we can draw it over the insect. This will be the adapter where we will attach a vacuum in order to draw the mist over the subject, and we can observe from there. Then on to here we can see the side profile of the testing wind tunnel and the bucket for the dry ice. And as you can see, this is the final setup where we'll have the dry ice in the bucket, which will draw through the wind tunnel with a vacuum hose, as you can see. With that, let's get on to testing. Here you can see our dry ice in our bucket. We've mixed it with water in order to create a nice mist. This is our setup. You can see as we turned on the vacuum hose and started drawing the mist through the straws. You can see I'm making a fine stream. We'll start out with a wasp. As you can see, the mist flows over the wings of the wasp, and we get quite a bit of turbulence because of the insect's body. And you can so we continue to see that the wasp's body shape is not very well suited for aerodynamics, but it does stand up to the force of the mist quite well. Here we can see the mist separating into turbulence right behind it. Here's another wasp that we've collected, this one with smaller wings. And this was body shape actually performed better than the first wasp because of the way it was set up. And we go on to testing on moths. So this is our first moth. The moth body shape performed really well with very little turbulence. As you can see, the stream barely separates. The moth's wings are thin and hold up to the stream very well. And this the moth's shape is very similar to what we'll see in airplanes such as like the B-2 Bomber or B-2 Spirit. So this actual shape has been tested in the real modern world. Here again we see another moth at a different angle. Finally, our last shot here, we can see same moth. It's kind of difficult to tell this is in this shot, but we aren't getting very much turbulence from the moth body type.
And start! In conclusion, exploring the intricate designs of nature, especially the aerodynamics found in insects, reveals a plethora of inspiration for advancing our technology. The evolutionary honed efficiency, adaptability to diverse environments, and the innovative solutions displayed by these creatures provide a roadmap for groundbreaking advancements in aerodynamics. By translating these biological marvels into engineering feats, we are on the verge of achieving reduced energy consumption, lower environmental impact, and unparalleled efficiency into transportation and technology. However, the journey from inspiration to realization demands meticulous testing and validation. Wind tunnels, water tanks, and simulation environments serve as crucibles where these designs, inspired by nature, are refined and optimized. Testing ensures that the promising concepts drawn from these natural world can withstand a rigorous demand of real-world applications, paving a way for transformative changes to aviation, automotive, and other industries. As we embark the wisdom encoded in the shapes of the insects and other living organisms, we embark the collaborative effort with nature itself. This partnership holds the promise of not only revolutionizing our technological landscape, but also fostering a harmonious coexistence with our planet. Through innovation and responsible testing, we have the opportunity to propel ourselves into a future where the brilliance of nature serves as a guidance beacon, leading us towards sustainable, efficient, and environmentally conscious advancements in aerodynamics and beyond. End.